Now we are discussing the problem the eigenvectors are in orthogonal in pair. For example, you have to discuss last class we are discussing eigenvalues and eigenvectors. Now we have to prove that eigenvectors are orthogonal in pairs. We will discuss the problem now. So what is the problem now? Verify eigenvectors of real symmetric matrix. Real symmetric matrix. Here A is given 3 minus 1 minus 1. Here minus 1 5. Here minus 1. Here 1 minus 1 3. We have to prove eigenvectors are orthogonal in pairs. Orthogonal in pairs. We have to find out 3 eigenvectors. That eigenvectors are have to prove orthogonal in pairs. We have to prove the vectors are orthogonal in pair. So what do you have to find out? First we have to find out the characteristic equation. Next we have to find out the eigenvalues. Next we have to find out the eigenvectors. That eigenvectors we have to prove orthogonal in pairs. We have to prove the vectors are orthogonal in pairs. So what is the first step? We have to find out the characteristic equation. This is a 3 by 3 matrix. And once again this is a symmetric matrix. So first of all we have to find out characteristic equation. This is our first step. So what is the characteristic equation for the 3 by 3 matrix? You know the formula. So here lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. What is our S1? So S1 is the sum of the main diagonal element. Sum of main diagonal element. So this is our S1. So here what do you have now? 3 plus 5 plus 3. What you got it now here? 3 plus 5 plus 3 will be 11. So 8 plus 3 will be 11. So S1 will be your 11. You got the S1 value. Next we find out the S2. What about S2? S2 is the sum of the cofactors of the main diagonal element. Sum of cofactors of main diagonal element. We have to find out the cofactors of the main diagonal element. So you know very well. So first you have to leave out the first row, first column. So here what are the element here now? 5 minus 1, here minus 1 3. Then leave out the second row, second column. Put the plus sign because you have to sum. So 3 1. Then here 1 3. Next we have to find out the leave out the third row, third column. So this is you have to 3 minus 1, then minus 1, here 5. You have to find determinant of this matter. You have to sum. So here 5 3s are 15, 15 minus 1. Here minus 1 get plus 1. Plus here 3 3s are 9, 9 minus 1. So here 5 3s are 15. So 15 minus here 1. So what you got now here? 14 plus 8 plus again 14. Have to add it now. So 14 plus 8 will be 22. 22 plus 14. What 22 plus 14? So this will be 36. So finally got the 36 for S2. Next we have to find out the S3. What is S3? S3 is nothing but determinant of A. You know how should find the determinant of A. So here take the element will be 3 will be there. So you can take 3, leave out the first row, first column. What are the element here now? 5. So 5 3s are 15. So therefore here 15 minus here minus 1 get plus 1. So into 1. Then here minus 1 will be there. I can take the what? Plus 1 because minus sign will there no. So I can put the plus 1 into leave out the first row, second column. So this will be minus 3, leave out the first row, second column. So minus 3 here, minus of minus I have to plus 1. So I get it the plus 1. Next here plus 1. So I can put the plus 1 into, leave out the first row, third column. So minus 1 into minus 1, you can get it the 1. So 1 minus 5 ones are 5. So therefore, we have to simplify this thing. How can to simplify here? 3 will be there, 15 minus 1 will be 14. Next plus 1 into here, minus 3 plus 1 will be minus 2. Then plus 1 into 1 minus 5 will be minus 4. We got 14 3s are, you have to 14 3s are 42. 14 into 3, no, you know very well. So 14 3s are 42. So therefore this will be 42, here minus 2, here minus. We have to simplify. 42 minus 2 will be 40. 40 minus 4 will be 36. So what is our S3? Determinant of LB will be again, this is also 36. We have to substitute the S1, S2, S3 in the characteristic equation. You know characteristic equation, you have to substitute S1, S2, S3. You have to find out the eigen values.